Alright, so this is going to be a tutorial on how to create MSU audio files. This is assuming you already have the audio files that you want to use, and you're just wanting to convert them for use with the MSU-1. Obtaining audio files is going to be a little bit out of scope for this guide. You can usually find, alternate soundtracks, whether that's going to be somebody having made covers of the soundtrack or remixes, or potentially later games in the same series that play the same songs but on newer consoles, and so you have better versions out like that. A good example of that would be Legend of Zelda: A Link Between Worlds. Played a lot of the same songs from the A Link to the Past soundtrack, but it was all reorchestrated in higher quality for the 3DS. So assuming you have these files, you want to convert. The process is actually really simple. The most time-consuming part, once you have the files that you want, is finding the loop points for them. And finding loop points, if you already know how to do that, then most of this video is going to be pretty useless to you. But if you don't, I'm going to show you how to create loop points in Audacity. So real quick, we're going to go ahead and open up audio file, one of the ones I'm working on right now. Oh, nope, not that one. This one. This is from the Chrono Trigger soundtrack. And if you've ever played Chrono Trigger, this should be familiar to you. So anyway, one of the first things you're going to do when you open up a file, you want to come down here to the project rate and set it to 44,100. MSU audio is always 44,100. So if you have, 32K or 48K like I have here, you're going to want to make sure that that is set to 44.1. You're going to want to come over here and make sure that this selection is set to samples. Now, you're going to want to come up here, and we're going to try and find basically the end of the loop. I already know where it is on this song. Now if you notice, the piano part that's playing right here is actually the beginning of the loop. It matches up with this. Except the high note right there, a little bit different from the notes that are played there. So I don't actually want to loop back there. Plus, the flute is sustaining a note throughout this whole thing. So even though that's the beginning, or that's the end of the loop, what we want to find is we want to find a place that actually matches both here and back here. The first place we're going to find that is here. So you can see, as you start to zoom in, you see these very pronounced peaks. And those are very helpful. Not every song is going to have really nice, well-defined beats like this, but songs that do, it's very nice. So, I'm going to listen. No, we're going to use this one right here. And also the fact that it has this nice flat front to it. That is another thing that makes it really, really handy. So, as we zoom in here, we actually see, so zoomed out here, you see this is a beat, this is a beat. And as you start to zoom in, you can actually really visibly see it, where this waveform has a particular shape and this waveform has a totally different shape over here. So we're going to try and find a loop point that's pretty close to this transition between the two waveform shapes. Now we're looking for something called a zero crossing. There's a very good reason for that. Basically, a zero crossing is going to be when you zoom in all the way, you see that the waveform is actually resting right on this middle line. Now the reason for that is to avoid a pop. A pop is what happens when you instantaneously change the level, which is what would happen if, say, you tried to loop from here back to here. What would happen is it would play this waveform, it would get all the way up to the top, and then it would instantly jump to the bottom. That would form a pop or a click. Now, you could just loop like that. You've got your high point to your high point, and you've got your low point to your low point. But it's a lot more difficult to find the right spot at some arbitrary point in the waveform. So what you really want is you want these zero crossings. The zero crossings come in a couple of different configurations, and I'll show them to you here really quick. There's 4 of them here. Really, only these first 2 are actual zero crossings, seeing as this doesn't actually cross the 0 point, but it does have this point right here where it does touch the 0 point. So that's still a useful waveform for our purposes. So this is what's called a positive edge, because the slope is positive when viewing it from left to right. This is a negative edge. This is going to be an upward parabola, and this one's a downward parabola. So right here, we zoom out a little bit to get a little more context on this. You can see very clearly we have a negative edge here, and we have a downward parabola here. So what I'm going to do is I'm actually going to write down this sample number. I highly suggest that you write down the sample numbers for all of the tracks for the entire track pack, because if you have to go back and make changes, you're not going to want to have to find these again. Also, for me, I actually have a script that I use, and all of my conversions are actually done in the command line, so it's all scripted. So I actually write my loop points into a configuration file, and that configuration file is what I feed into my script, and the script does all the work for me automatically. Once I actually find all of the right parameters, like the loop points. So whether or not you're going to do it that way, I still would highly recommend writing down your loop points, because we're going to find here in just a second, I'm going to select back here, start playing it, and now the loop point's gone. So if you don't have it written down, you've already forgotten it. Or maybe you have a good memory. I don't. So that point we're looking for is right here. And really quick, let's refresh our memory of what that sounded like. 4, 8, 1, 9, 6. This is the part that we're listening for. So just those couple of notes. Okay. You're right here. Here we're going to go ahead and zoom in. And you can see the same thing. Now, this waveform looks a little bit different than the other one, and that's okay. But you can still see this very clear transition between the two. So really quick, now that I kind of have a rough idea, so remember, looking for a downward that coincides with, or a negative edge on top that coincides with a downward parabola, and we don't quite have that. We have what's almost a downward parabola, but really it just kind of flattens out. And that's okay, it doesn't have to be exact. We're still on a zero crossing, we're still in basically the same shape. And we can check this, going back. And we can zoom out, and we zoom back in. And I'm doing this by holding the control key and using the scroll wheel on my mouse. You can see right here. So if we call this the actual transition, from the transition you go backwards and you have one positive edge and one negative edge. Now here, I would say that this is our transition. at least judging from the top waveform. The bottom waveform, it might be this one down here. But you can see, so we've got a positive edge, a negative edge, a positive edge, and then another negative edge. But like I said, you could also call this our transition, and then you've got the same thing as before. This is our transition, then we just have the one positive edge and the one negative edge. But if we're just off by one period of the waveform, that's not going to be a huge deal. This still tells us that we're really close, and that's a good place to be. So now, to actually test our loop point, we want to be able to listen to it. So in Audacity, the way that you listen to a looped selection is by first you select it, then you hold the Shift key, and you'll notice that it changes this icon from play to a loop play. Now once you have started playing it by holding Shift and then clicking, you're going to want to click down here somewhere in the empty space, and it's going to deselect this. You'll still see the selection up top here on the time bar, but it'll deselect this. And the reason you do that is you have to deselect it in order for the arrow keys, or when you deselect, it changes the behavior of the arrow keys. So the arrow keys allow you to skip forward and backwards in the song while it's still playing, and that's very helpful because it allows you to skip forward in the song, and then you don't have to listen to the entire loop just to get to that endpoint. Now another way that you can skip around while it's playing is, again, by holding Shift and then coming up here and clicking. And we can actually start, I believe, I'm going to try this, I believe you can do this even from it being stopped. I think you can hold Shift and click up here, and then it just starts playing right there. Oh, yeah, that works too. And then you can just click again, and you can listen to it again. So when you're checking your loop points, I suggest turning your volume up quite a bit so that you can listen for subtle issues, like pops and clicks. But sometimes it's not. It's not just the pops and the clicks. Sometimes maybe you picked the wrong spot in. Maybe you went. Maybe we picked here, right? So we picked the wrong spot. Let's just find a zero crossing real quick. I think there's going to be one like right here. Yeah. So we pick our spot. Now listen. And see, it sounded like a pop, but what actually happened was it actually skipped forward because our correct loop point was up here. And so it actually skipped this whole section of the song and never played it. And you can hear these subtle issues when you're listening to it. And like I said, it helps if you turn the volume up. And so here, let me 4819. Okay, there we go. So once we have our loop point, one other minor thing. So you notice we picked our zero crossing here, and we picked our zero crossing here. We don't actually quite want that because we're going to be jumping back. It's going to play the zero crossing at the end, and then it's going to jump back here, and it's going to play the zero crossing again. So we actually want our loop point to be forward by one more sample. So it plays the zero crossing at the end, jumps back here. It doesn't play it again, it plays the next sample. So I'm going to write down that sample number. And then, once we have both of those written down, now we're ready to export the file. So we're going to select everything because we're actually going to want to select just the end here. But it's really easy to just Control A to select everything, and then you come here and we type in our endpoint and cut. Now that we've done that, we can export the audio. And we're going to export as 16-bit PCM wave, Microsoft's format. We don't want 32-bit float PCM or any of these other options. We want wave Microsoft signed 16-bit PCM. Tags don't matter. The header is going to be stripped off once we convert it. So we export. Now you need a program called Wave to MSU, and I will go ahead and link it in the description for you to download. It's a command line program, so you are going to have to get your hands dirty with the command line. Pull it up here. So here I have it in a subfolder called bin, so that's the reason why I'm doing this. But so what you do is you type wave to msu.exe. The first parameter is the output file. In our case, it's there. And then we have our loop point. Pull that up really quick. You specify that with the -L parameter. And then you just type in 2835571. And there you have it. Now, if you forgot to set your project rate, and if I'd forgotten to do that, it would have still been at 48K. Wave to MSU will not accept that. It has to be in 44.1K for this program to even use it. So that's a good sanity check to make sure whether or not you got it wrong. Now, if you did get it wrong, and your loop point and your ending point are in the wrong numbers, like let's say you're just, let's say you're here, and so now our loop point is, or our ending point is, 5,241,905. What you can do is you can open it back up, go to the original project rate, type in your sample, and then click and change it, and then you'll see it actually recalculates the sample numbers for you. So if you do make that mistake, you don't have to find them again. You can just type in your original numbers and then have Audacity calculate them for you. So now the one thing I haven't covered is normalization. Normalization is basically volume leveling. And it's important because if your audio tracks are too loud, then you're going to hear that when you go to play the game because you're not going to be able to hear the in-game sound effects. Or if it's too quiet, your sound effects are going to sound really, really loud, and you're just going to think that the soundtrack's really too quiet. So it's important to normalize your audio tracks to the level of the original game. Now, Audacity does have a normalize function. Unfortunately, Audacity's normalize function utilizes what's called peak amplitude. And what that means is that it's basing the volume off of the very, very highest peak and the very, very lowest peak, here or maybe here. And if you say -12, or if you say -20 decibels, then what it's going to do is it's going to take this highest point and it's going to adjust that to -20 decibels. Now, this is a problem because if all you care about is the peak volume, I'll show you another one. All you care about is the peak volume, or the peak normalization. We just take this section of audio, for instance. If you normalize these to the same peak levels, this track up here at the very top is going to sound much louder than the one down here. And it's because what you hear is actually, the way your ears hear it and perceive it is actually an average. So the fact that you can see that there's all of this going on, where here this is basically silence and all you're hearing is just some background noise echoing. Your brain interprets that as this being quieter. And you don't want that. So what you need is what's called RMS normalization, and Audacity doesn't support it. So what I have to do is you export your WAV file, and then I use a separate application. Well, I don't even use Audacity for creating the WAV files, but even still, I use a separate application that just goes by the name Normalize, which isn't really easy to help find it, but I will also link to that one in the description. Its homepage is on a site called nongnu.org. But that aside, what it does is it actually calculates the average level across this whole thing, and then it sets the new target volume such that the new average is what you want it to be. So if you set all of your tracks in the whole soundtrack to the same RMS levels, they should all sound the same in terms of volume levels. Whereas if you used peak normalization, then different tracks that are more dense, you will, like this one, are going to come out sounding a lot louder than tracks that are not as dense. So unfortunately, like I said, you can't really do it in Audacity. You have to use an external program for that. There's a bunch of different options for that. So my workflow, if I were to be using Audacity for actually exporting tracks, you come in, you do everything I just showed you in Audacity, you export your audio track, then you take your WAV file and you normalize that WAV file before running it through Wave to MSU. Then you run the normalized track through Wave to MSU. So once you've done that, you have your audio track, and if you want to double check that it worked and you want to listen to the final result, Audacity can actually import those files by going to import raw data. And here's the one that we made. Here, these are some other ones that I've done, but this is the one we just created. And so here you're going to get this this dialog. And the correct settings are 16-bit, signed PCM, little endian, 2 channels stereo, and offset is 8 bytes. The reason for that is the MSU-1 file has a what's called a file header. In a WAV file, your file header is things like your artist tag and your album tag and your track name and your track number and all of that stuff. That's stored in the header. And you don't want the header to be interpreted as audio data. So in this case, your header is 8 bytes long. You don't do that, what you will see, you zoom in real close, see this little spike right here. That is those 2 samples are that's the header being interpreted as if they were audio data, and they're not. So we come in here, 16-bit little endian, stereo, 8 bytes, and we can see there's no more spike there. Now, if we see where it's cut off at the end like it should be, Control A, and you can see that our length is exactly what it should be. So now if we type in our loop point, we can into the loop again. That doesn't actually sound right. Did I type it wrong? Strange. So let's go ahead and zoom in. Oh. Oh. That's what happened. I typed in my ending wrong, and so it's actually cut off early. That's 816. It should be 819. And so that's a good example right there of why it's good to actually listen to your final output file and make sure that it actually makes sense and that it actually turned out the way that you wanted it to. So to show you one that's working correctly, I will go ahead and import one of these. Well, this is actually the exact same track, but this one has been normalized. And you'll see right here that it's a lot quieter. Now I find, the level is going to vary from game to game, but I find that a very good starting point is going to be negative 18 decibels RMS. From there, for the most part, maybe the loudest I've seen is like negative 12, and probably the loudest is the loudest is negative 12, and the quietest is negative 24. But typically, most of what I've seen has been negative 18 or negative 21. So negative 18 is a good starting point. Go from there. And you can see, okay, so we got this one right, 4819,600. And 283571. And there we have it. A nice seamless loop. So you do that for all of the tracks, and then you have yourself an MSU-1 audio pack. And this is work I'm doing right now for Chrono Trigger. And we'll get these files online as soon as I can. There's already a pack available by Blake Robinson. This pack is by another guy here on YouTube, Dracula M9 Anti-Chapel. And he previously had released all of his tracks in MP3 format, and he was kind enough to redo them all as FLAC files so that we've got nice high fidelity audio. So anyway, that's basically all there is to it. If there's anything I missed or if there's any questions, feel free to ask them in the comments and I will do my best to respond. I will eventually be also turning this into a write-up on my website, but for now it's just easier to go through and record myself doing it, and then I can actually use this video as a reference as I'm doing my write-up. So anyway, yep, there it is, MSU-1 audio. Now, hacking the games to actually get it in there is a whole different matter altogether, but this should at least help you out with creating the audio files.